So let's go ahead and take a look at some examples of this product rule on the next page. If you take a look at the first one, you might actually feel like multiplying those two quadratics together to get a quartic polynomial, and that would be perfectly all right. You can go ahead and go through the power rule from there, shortcut, no problem. But just to practice the product rule, I want to see if we can do that without actually multiplying them together. So we'll label our derivative f prime, and we'll go through 1 d2, okay, the derivative of the second. If it actually helps you to label 1 and 2, go ahead and be my guest. So 1 d2 plus 2 d1, and we're done with our product rule. So you can leave it like that, but just as an FYI, more often than not, the final answer on a multiple choice type question is going to be the simplified form. So I highly suggest cleaning this up, rewriting it, combining like terms, see what you can get in the end. So if we multiply these two quantities together, we'll get 4x cubed plus 6x squared. And then going through kind of a FOIL distribution process here, we'll get 4x cubed plus 3x squared minus 12x minus 9. So combining some terms together, looks like we get 8x cubed plus 9x squared minus 12x minus 9. So there's our final derivative. Again, this is representing the slope of the tangent line at any point. If we take a look at the one directly underneath it, notice how we're multiplying two things together. So to find the derivative, we'll go through 1 d2 plus 2 d1. So our first function is x cubed. Our second is sine, so d2, the derivative of sine, would be cosine. Then we have to add 2 times d1, so the derivative of x cubed would be 3x squared. We can rearrange some things here. If you would like to rewrite it, you can move the 3x squared in front of the sine x. And I say we're good to go with that derivative. All right, let's go ahead and take a look at G. Notice how we are multiplying two things together, and it might be beneficial for us to rewrite the square root as x to the 1/2 power to help us actually go through the product rule, because we might have to use that power rule derivative shortcut in the process. So let's go ahead and tackle the derivative. So 1 would be the x to the 1/2 times the derivative of the second, so 2x minus 3. Then we have to add 2, which would be the quadratic, times d1. So we need the derivative of this square root. So using the power rule, we'd have 1/2 x to the negative 1/2. Again, the answer on a multiple choice question is most likely going to be the simplified form. So we can start to distribute in some of these quantities. Now, when you're distributing x's to powers, remember that we use that power property where we add the powers together. So this would be 2x to the 3/2 power, if we add those powers, and then minus 3x to the 1/2. Okay, so we can distribute in that x to the 1/2. For the next one, we can distribute in the 1/2 x to the negative 1/2. So plus 1/2 x, and if we add those powers, that'd be 1.5, so we can write that as a fraction. And then minus 3/2x to the 1/2, okay, if we add those powers together. And then distributing into the last term, plus x to the negative 1/2. Now let's see, combining like terms, we have 2x to the 3/2 plus 1/2 x to the 3/2, so 2 plus 1/2 would be 2.5. We can write that as a fraction. We have some 1/2 powers here, so negative 3 minus 1.5 would be negative 4.5, but again, we can write that as a fraction. And our last term has a negative power, so if you want to move that to the bottom of a fraction, you can. I apologize if that's kind of small, but just to reiterate, this power is 3/2, and then 1/2, and then 1/2. Let's try the next one. We're multiplying two things together, so going through our product rule, we need 1 d2. So the derivative of cosine is negative sine. And then plus 2 and d1. So the derivative of 3x plus 2 would just be 3. If we clean that up a bit, okay, we can do some distribution. So negative 3x times sine minus 2 times sine. And then plus, we'll just clean up this last term, 3 cosine of x. All right, let's go ahead and try the last two in these boxes. Now, I have a little typo here. Notice how it says g of x, but our variable is actually theta. Those should actually be matching. So if you want to change these to x's, you can. Okay, if it helps you, might not be a bad idea. So as we look through this function to help us find the derivative, our first term is 3x, and that kind of fits our power rule shortcut. So the derivative of 3x would just be 3. If we take a look at the next part, we need to add the derivative of x times sine of x. Notice how when you actually say it, you say that times or multiplication. So that's kind of cluing you into product rule. So for our second term here, we're going to have to go through the product rule process, 1d2 plus 2d1, to help us find that derivative. So our first function is x times the derivative of sine would be cosine, plus the second function, which is sine, times the derivative of the first function. Okay, the derivative of x would just be 1. So it looks like we're left with 3 plus x cosine of x plus sine of x. Moving on to our last one, notice how if you actually look at it and perhaps say it out loud, this function would be sine times cosine. So we're going to go through our product rule because we're multiplying two functions together. So our first function is sine. The derivative of the second function would be negative sine. Then we have to add the second function times the derivative of the first function. Okay, we have to remember those trig derivative shortcuts. Cleaning it up, we'll have negative sine squared, because we're multiplying two sines together, plus cosine squared. All right, and we'll leave it like that. Some of you might be tempted to use an identity to rewrite this even further. You could, but perhaps you can just leave it the way it is. Again, if it's a multiple choice question and it doesn't match this exactly, you may have to use an identity somewhere, but for now, we'll say that's just good to go. All right, let's go ahead and check out this last one. So find the equation of the tangent line to this graph at this spot. So an equation of any line, we need to first figure out a point and a slope. Now the slope comes from the derivative, so it might be in our best interest to try to find that first. And notice how this function is t squared times cosine. So that word times in there showed up. We're going to have to go through our product rule shortcut. So we'll have 1 d2 plus 2 d1. If we clean it up a little bit, negative t squared sine of t plus 2t cosine of t. I encourage you to go from there and see if you can figure out the equation of the tangent line at that spot.